So let's take a look at number 111H. This sequence, we're to determine whether the sequence converges or diverges. Of course, if it converges, finding the limit of the sequence. So here's the sequence. And a lot of students incorrectly just assume right away that this limit of this sequence a sub n does not exist because they see this -1 to the n, which changes sign, right, as n varies between even and odd numbers. And they think like it bounces back and forth between two values, but just be careful here. Don't jump the gun. Notice it's all over n. And if I just start listing the terms of the sequence when n is 1, of course, the denominator is 1. I get 4 plus what? -1 to the first power is -1, and this is 3 times -1, so that's -3. 4 plus a -3 is 1, so I get 1 divided by 1, I get 1. But when n is 2, -1 squared is +1, I get 4 plus 3 is 7 up top. Of course, n is 2 in the bottom. What happens when n is 3? Well, now it's -1 cubed, so this is back to -1. 4 plus a -3 is back to 1. The bottom n is 3. Okay, and this continues. Notice that this expression up here, 4 plus 3 times -1 to the n, is going to bounce back and forth, yes, between 1 and 7. However, the denominator, right, is increasing by 1 each time, of course, when n is 4, when n is 5, when n is 6, and so on. So be careful. It's not just bouncing between 1 and 7. So if I had a sequence that was just 1, 7, 1, 7, 1, 7, yeah, that limit would not exist, right? Bouncing back and forth between 1 and 7 forever. And we would say that sequence would diverge, but this is all over n, right? So these are actually a little different. And what you can look at, if you think about it, if I take the absolute value of the a sub n's, of course, they're all positive already, notice that that will always be less than or equal to 7 to the n. Okay, here's the sequence for 7 to the n, by the way, right? Where I just have 7, I can write 7 over 1, right? 7, n is 2, n is 3, n is 4, n is 5, and so on. And you can compare, right, that these values in our sequence are always less than or equal to that, right? 1 is less than 7, 7 halves is equal to 7 halves, 1/3 is less than 7/3, right? 1/5 is less than 7/5, and so on, right? These terms corresponding are always less than or equal to that. Well, if the absolute value is less than this 7 over n, that means our values in the a sub n are trapped between these two. Okay, technically, we could even say it's trapped between 0 and 7 over n, because we know they're all positive. But either way, the limit as n goes to infinity of 7 over n is clearly 0, right? I mean, 7 divided by something going to infinity is going to go to 0. That's obvious. And so both of these sequences that sort of bound our sequence, both are convergent, and their limit is both 0. And so what do we have? By the squeeze theorem, right? The limit as n goes to infinity of a sub n must also be 0. So the limit of our sequence is indeed 0 by the squeeze theorem. And so you need to take a careful look. The squeeze theorem comes into play sometimes. It helps sometimes to list the first few terms of the sequence so you get a feel for what's going on. Okay, I hope this helps with number 111H.